Okay, welcome back. We're going on to section 16.3, which is the theorem about angles in a circle. Okay, take any 2 points on a circle and the angle they subtend, which just means the angle they make at the center, is twice the angle they make at any point on the edge. So this angle would be equal to this angle, etc. Okay, so that angle would be equal to that angle, and this angle will be double that angle. So if this angle is x, this will be double x. Very simple. Lovely theorem. Okay, so straight away we're looking at this, and it really doesn't look like a standard theorem, but I can see what's going on here. It doesn't look like a straightforward application. So what we have here is special case in that there's a diameter across here, making this 90 degrees, which basically makes this x and this 65 because we have two isosceles triangles in here. Okay, now it wasn't explicitly stated, but that's a radius and this is a radius, making the angle there 65 degrees. And of course this is also a radius out here, making this angle x. So that's the crux of it anyway. The minute you see that and you do a quick little bit of thinking, you've more or less solved whatever they're going to ask us. Let's take a look at what they do ask us. The angle from O to B to C. Okay, x. So we're just going to have to do a little bit extra here. Well, we have that x. Up here we have an x on this side and a 65 on this side. So we know that x plus 65 is equal to 90 because it's the right angle up here, because it's an angle opened up from a diameter, which is always 90 degrees. So that makes x equal to 25 degrees. Okay, so 25 degrees is the angle here. Now we're going to have to see where they're talking about here, from A to O to B. From A to O to B is this angle here. Well, we know x is 25. So we know the two x's in this is 50. So we know that this is 130 because it's 180 minus 25 minus 25. Finally, the angle at B, OBA. OBA. Sure, we've already got that as x, and that's 25 degrees. Okay, nice. On we go to this one. Avoid reading when we can. Looking and analyzing a diagram is much more fun and much easier to do, and I'm going to be able to answer everything without looking at the questions because they're going to ask me what's B, which is double 48 using the angle theorem, the center circle angle theorem. That says the angle in the center is twice the angle on the circumference of the circle. Okay, so what's 2 by 48 for B is 96. Going there. And A, of course, is 48 because it's a corollary that if two angles stand on the same chord or the same arc, it's all the one, they have to be the same. So 48 stands on these 2 points, and so does this. So A equals 48. Another one. Okay, so a very interesting corollary from this. Another one is that while most quadrilaterals are not cyclic, meaning you can't put a circle around them, ones that are cyclic have this condition that opposite angles add to 180. And we know that because we can draw in these two and say, so if this is 2x, this is x, and if this is 2y, then this is y. But 2x plus 2y is the angle at a point, which is 360, and half of that is x and y has to be 180. So opposite angles to this. So I think that's what this would be about. Let's get stuck in and see. Opposite angles in a cyclic quadrilateral equal 180. Sum to 180. So let's see what we've got. We got 80 here, so we've got, well, I better blow this up a bit so we can see what I'm saying. I got 40 degrees here. And if I have 40 degrees there, I have 140 degrees here. And let's go take a look at what they want. What do they want? Oh, there's loads of examples in this one, isn't there? So they want ACB. A to C to B, we've done that already. 40 degrees. And they want ADB, which we've done already, which is 140 degrees. Lovely. Okay, on we go to example 4. Let's take a look at the diagram. Right, we have 110, so we have 55 up here. Let me write it outside so I can write it really big. 55 degrees here. There's half of 110. And okay, let's see what they want. I'm thinking I might need to construct this and put a 30 here because it's isosceles. And if I'm doing that, I'm going to have 25 here and I'm going to have 25 here. Okay, so let's see what they actually want. They want ACB. ACB, 55, that's done already. And they want OAC. OAC, and that's done already. 25 degrees. Okay, let's do questions 3, 6, 9. Okay, so any angle built on a diameter is 90 degrees. So we'll have 90 degrees here and here. This is a right angle triangle, and so these are complementary. They make up a straight angle. They make up 90 degrees. So C is 20 degrees. And D is 90 degrees. Nice question. And this is an isosceles triangle, so we have another E down here. This is a right angle, even though they didn't make it look like it, but it is. And this is a right angle. Okay, so that makes E 45 degrees because E and E must add up to 90 and they're the same. And this one you see is skewed a bit, it's not isosceles, but these two have to add up to 90. So F equals 90 minus 37, which is 53 degrees. Okay, wasn't that just fun? And very easy. I hope. Just waiting now for the pictures to come back to me. I think one note, see where I'm at. That's great. That's what I get for being on a very old laptop. Crawling. Waiting. Okay, so that's all three of them done. We've got question 6. Okay, so the angle subtended at the center. Now what's this angle subtended? So what we're talking about is we're opening up the angle from this arc or from this chord, as you like. I think the arc is a nicer way to look at it. It's technically the same thing. And we're saying, hey, if you go all the way to the edge of the circle, that angle will be half what you get if you go to the center of the circle. So I'll just represent that graphically by 2 dots and 1 dot. Okay, so we know the double of the angle is 126. The double of angle A is 126, so half 126, half 12, you get 6. Half 6, you get 3. So A equals 63 degrees. half of 92 is half of 90 plus 2. It's 45 and 1, it's 46 degrees. And we're doing the other way around now. We're doubling 59 degrees, doubling 2 by 59, 2 by 50, 100, 2 by 9, 18, 118 degrees for C. Great, on to question 9. Hold on now, there's loads of 6's in here. Wow. Okay, so this arc subtends, just meaning supports the angle 32 and supports D, which has to be also 32. What's going on here now? Did they tell us this goes through the center? No, it doesn't. Wow, I don't know what's going on here. And now I lost the yoke again. I'm gonna have to deep and do myself a little bit of thinking. But hold on. This is an arc that supports both E and 78, so E equals 78 degrees. So it was actually just a straightforward application of two angles supported by the same arc. Okay. Now we go here. Half of 206 is 103. Okay. Keep rolling up too big and it disappears. Anyway, it was 21 degrees for the next one. Let's stop rolling up, and also we don't seem to need a calculator under this. Let's see how we get on if I just don't try to that time hopefully it will behave itself from here in. So G is 21 degrees. H is standing on the same arc as 47. So H is 47 degrees. And I is standing on the same arc as C2, so I is. And same as 25. And K is the same as 25. And J is the same as 75. And I'd love to do this anyway. That would be 135 because opposites are 180. That would be 76 because opposites are 180. H would be 100. G will be 143. And so on in that vein. We'll go on to question 9. And they want the angle at CACB is 70. They want OCA, which will be 30, because by the time you've drawn it, you have an isosceles triangle here, so the base angles are equal. OCB, well, I had a 70 up here already, so now I have a 40 in there, and now I have a 40 here, so OCB is a 40. And OBC is also 40. It's in the same isosceles triangle. Question 10. Don't have to do it, but I'm going to do it anyway. X is 50. The circle angle theorem. And 30 is supported by this. No, it's not. Yeah, we're going to get X. Yeah, there's a 50 up here. Now we draw this up here. This very important construction line, which puts 30 there because of the isosceles. Puts 20 here, which is what makes up to 50. And if 20 is there, then Y is 50. Y is, 20. So Y would be 20. Like I said, X is 50. So on. You can do more then if you like yourself. On to question 12 now. 50 means this is 100. I have a fair idea I'm going to need it. And now that I know that this is 100 and this is isosceles, then I need to make up the extra 80 with a 40 and a 40. Which means that's 40. Okay. Well, look, I know this is 93 means I can get these two very easily. Do I need to? Probably. No point in thinking about it too much. Let's go ahead and get it. So if that's not 93, these are 43 and a half each. Is this a right angle triangle? Not necessarily, no. Where did that take me? Good north a center, but there is no north in this one. Yes. And it's definitely not the center. Because if it was, this wouldn't be 93. You got that bit right, but that's not what I need. Oh, I have it. Of course I have it. Yeah, 43.5. So there was problem solving there. It took me a while. So this is standing on the same as this. And we know this is 43.5. So x equals 43.5. Nice one. Okay, believe it or not, this is 60 because it's double 30. 15. Okay, gone again. I think I need to remove the keyboard, but just have to see. Run all the way up to question D. Yeah. So I'm just wondering, is there anything given in here that isn't here? Okay. A cyclic quadrilateral, we can see that anyway, so that's not new. AX is equal to XB is not new because it's given. So we're to prove that AB is parallel. So we're to prove this, that that's parallel to this. So that happens in a trapezium. Now what's the story with a trapezium? Show that they're parallel. Don't really know what to do here now yet. It's just, so what you do when you don't know what to do is you get your hands dirty, you start doing anything at all. It's correct. So that angle equals to this angle. I think. And why? Really don't know. Hold on, I have something. Where's my pen gone? So if you look at this CB here, it supports this dot here, this angle. Look, I'm not sure about that. So let's say it supports that, but it also supports this. Okay. And then this, which is supported by DA, also supports this. So these four angles are equal. Now I'll drive on from that and say that these are definitely equal because they're vertically opposite. And if these base angles here of this upside down triangle, this one here, this yellow one, then are equal, then it's an isosceles. So these are equal. But I can't use, I'll use 3 ticks because I've used 2 ticks on the lower ones. So those two are equal. And that makes these congruent. And these lower two are congruent. But how? Yeah, I think the fact that these are both x and you have 2 isosceles triangles, I think that has to say that these are parallel. Like, just think about it. How can you have 2 isosceles triangles, even if they're one is bigger than the other? How could, if these are both isosceles, doesn't that mean that that's parallel to that? Do I need to prove it though? It's kind of obvious, but that's not enough. Here we go. So I also have this angle here is the same as this angle here. And something similar going on. Let me just use a single arc here and a single arc here. And they're equal. So when all of that is done, then you can add these two together and say these, are they alternate? You know, we have, so basically one of the theorems about, say, 2 lines, I'll just make them look like they're parallel and a transversal, is that if the alternate angles are equal, then these are parallel. Okay, so if, yeah, and that's it. Sure, I had it ages ago. Because that equals this. And the reason they're equal is because the top and the bottom is isosceles, and they're this in common, the vertex angle, which has to be the base angles are equal. And that's it. There's my proof. It took me an awful long time, but I stuck to it. And that means I've got my alternate angles. And once you've got your alternate angles, then you know these are parallel. So it's a case of that alternate angle theorem backwards, or the converse. Now we 16, 17, 18. So they're giving us a lot of extra information here by saying those 2 angles are equal. Better see what, hence show that, oh, this is the power of a point theorem, which I'll probably talk to you now about. AC times BD, that multiplied by that is equal to AD is equal to that multiplied by that. BC. Okay, well, we want to make this look more familiar. So let's make it look like a proportion. So AC divided by, you can divide it by AD by bringing down that AD from there is equal to PC divided by BD. So these are equivalent. Now let's see what I can go to. I'm truly problem solving now because I absolutely do not know how to do this. I haven't done it before. But I am problem solving. I'm saying I think I prefer this because this might just come about because of similar triangles. So I have to find out what triangle is AC on. It's there. What triangle, and where's AD? A to D is here. So I can think of, let's actually, just for a minute, instead of putting AD down there, let's put PC down there. bring the AD up here. So now I have that divided by that, which is part of this triangle, this yellow triangle here, and AD over BD. So yeah. So now I want to show that this green triangle here is congruent to that smaller yellow triangle, because once I do that, I'm going to have corresponding proportions from in here. Okay, so I need another angle. So I've got my single dot. Let's go with a blue dot, and I'll say those two angles are equal because they stand on this, and that's it. So now I have B. Where will I start? I'll start up on A, and I'll go ADB, A to D to B. Okay, which means from the red angle to the blue angle is similar to A to C to P. Okay, and then once I have that, I can scratch all of this and say from this I know that AD there, because these are written in congruent form, meaning they're going around correspondingly as we go through them. So from A to D should be over A to C. And I have both of them here and here, that's perfect. And from B to D, which is opposite the red dot, should be divided by the other opposite the red dot, which is PC. And I cross multiply that, that goes up there, that goes up there, and then I get that. Lovely. Okay, that's 18. And that's the end of that. As always, students, I will see you in the next one.